So what are we doing this time? In your little, when you're ready to do the 1/4" cable, you're going to have a little coil of cable here. This is a different kind of cable though, as you'll see. And we've got a couple of N2PX connectors, mono phone plug. We sometimes call these TS connectors, tip sleeve, because you only wire 2 things up to them as opposed to 3. And what we're going to make specifically is a guitar instrument cable. Okay. The reason that there's only 2 connections on there is that guitar cables are not balanced. They use a different kind of signal. It's an unbalanced high impedance signal, as opposed to microphones that use unbalanced low impedance signals. What does that mean? It just means that the microphone signals can travel a lot farther, the cables can be a lot longer, and they won't pick up noise and interference, even though they're traveling really far. You can run a microphone cable hundreds of feet and it's just fine. A guitar, though, because of the way that those pickups work and everything, it's not really designed to run really far because they're expecting that you're plugging it into an amplifier. And that amplifier is supposed to be right next to you. And so, if the amplifier is going to be right next to you because you have to hear yourself play this guitar, then there's no sense in putting a bunch of electronics in place to allow you to run that cable really far. It actually sounds better and you can do more with that signal on a short run if it's unbalanced high impedance. So it works better that way. You just plug it straight into the amp and you're good to go. So the guitar cable does everything that the microphone cable does. Well, the microphone cable does everything that the guitar cable doesn't. So guitar cables can't run very far, really no more than 15 feet. If you ever see an unbalanced guitar instrument cable that's more than 15 feet, cut it in half and make 2 cables out of it. Okay? It's just not going to be very effective. It's going to hum. That's probably the first thing that's going to happen is it's going to hum if it's more than 15 feet. Okay? Other things might happen too, but it's probably going to hum. So 15 feet, that's about it. If you need it to be longer than that, then you have a couple of options. We don't need to get into the weeds on that, but you can plug guitars into like wireless transmitters, which can get you some distance. You can also use things called direct boxes, which that's a audio electronics project I'd like to do someday, is we'll make direct boxes, but not this time. But what a direct box does is it converts that high impedance unbalanced signal to a low impedance balanced signal like microphones, and then you can shoot it hundreds of feet just like you can a microphone. Now, it's hard to take it from there into an amplifier, because amplifiers aren't really designed to take balanced low impedance signals. So most direct boxes have just like literally another 1/4" connector on it that's completely wired together. There's no electronics between it, so you can just like jump it straight into the amp from there. And then there's a little transformer that balances it and lets you send it onto the other side of the room unbalanced, on a balanced low impedance line. So you have that option as well. You got a question?
I think you said that mic cables are unbalanced low impedance. Are they balanced?
I said that. If I said that, I said that wrong.
Okay, I just want to make sure I corrected that.
Microphone cables are balanced low impedance. Okay. And guitar cables are unbalanced high impedance. Thank you for catching me. All right, so here's what we're going to do. Here's our cable. We're going to start more or less the same way as we did last time by putting the boot on and the heat shrink. So here's the boot. I'm going to put the boot on. I almost forgot. I was about to get my knife out and strip the jacket off this thing before I put the boot on. Once you got the boot on, then you're going to strip the jacket. So again, you want to do about 1 inch, and you're going to spin it around just like you did before. You're going to find this jacket is a little softer than the 8412, but you're going to cut through it a lot easier. So just be careful, because you don't want to cut into the copper sleeve that's on here. And there's no twine between the jacket and that copper sleeve, unlike the cable we used last week. So you got to be even more careful not to cut into that copper wire, because that would be bad. And then I'd make you cut it off and do it again. All right, I did it. So you can see that I've got bright copper sticking out on whatever side I want. So now I can just pull this off, and it'll slide right off, unlike the Belden, because there's no twine that's like sticking to anything. It'll just slide right off in a perfect little tube that you could, I don't know, do nothing with, but it is cool. And what you got now is a braided copper shield, which should look familiar to you. It's very similar to the one on the Belden, other than it's not tinned like the Belden is, so it's just raw copper. But you still got to pick it apart. So we're going to pick it apart. Like so. Now, assuming you didn't cut into the wire, you should be able to, be fairly rough with this, and you won't have to worry about losing any wires. But, couple of braids at a time. You don't want to start all the way at the bottom and go up, otherwise it'll just become a mess. But you can do a little bit at a time, and eventually you'll get it open. Almost there. Okay. A little bit more. This is working so much better now that I cleaned my magnifying glass. I can see. All right, I think I got it. So I'm going to just kind of divide it here, gather it around the other side, just like I did before. Gather it kind of as tight as you can, and really kind of give it a good pull. Rock and roll it back and forth until you get it really gathered, and then you're going to twist again. Really, really tight. Pull a little bit as you're twisting so it stays straight. Like so. Now, before we deal with this second jacket, we're going to tin this wire in this case, okay? Because getting this jacket off is a little gnarly, so we want to make sure that this copper sleeve is not, or shield is not going to unravel on us while we do that. So that is the next thing. All right, wake up. My soldering iron went to sleep. Let's give it just a sec to heat back up. $600. Oh, there it goes. tin my tip real quick.
You know, I really hate the way that solder is spelled. It shouldn't be spelled like that.
I agree.
You don't like the L? Is that the problem?
Like necessary L.
It should be double D.
I'm a big fan of silent letters.
I don't think it should be double D's. I think it should be S-A-U-D-E-R.
So sometimes, if this, for some of you this happened, but if you leave your soldering iron sitting in there heated up for a long time and don't do anything with it, it'll start to oxidize, and then solder doesn't stick to it anymore. So you can use that little tip tinner to bring it back, and then it should work. But also, tips don't last forever, so. All right, here we go. Same routine as before. We're going to let this soak in and coax that little bead down the wire, nice and smooth. Okay? See that? Just like before. All right, now I can deal with this thing. Now what you're going to notice here is this jacket inside is quite a lot thicker than the one you had before. And to know how much you got to take off, you're going to need to investigate the different parts here of your connector. So ultimately what's going to happen here is this little strainer leaf is going to sit here, and you really want the teeth of this thing to grip that thick jacket here. So what I like to do is just kind of stick this on here temporarily and make sure that I'm lining all of this up, because if this ends up being there, the strain relief. Okay, so if the strain relief touches there, then I'm going to want to take off not a whole heck of a lot here, it looks like. Because ultimately this wire slides into there. And therefore, I'm not even going to take half. I'm going to take maybe a third of this off. Okay. You take a whole lot more than that, and well, I mean, you could take more actually, because if you take more, the strainer leaf will just slide farther down. But ultimately, you'll see we're going to have to trim this very specifically. So I'm going to take about a third off, maybe as much as a half. If you go a little too far, it's okay. But you don't want to do too little. You really ideally wouldn't do too much, because then you got to figure out what to do with this. So I'm going to aim for about a third off here, and then we'll see what happens. Now, this jacket is pretty thick, and I haven't had a whole heck of a lot of success using the traditional wire strippers to cut this. I found it kind of mangles it a little bit, so I prefer to just use the knife again on this kind of jacket, okay? So I'm going to take it to about there. And this jacket is a lot tougher than the other one. There we go. But you can cut it pretty well if you get onto it, and it comes off. All right, now I'm just going to twist this good and tight, and then I'm going to tin it. So you want to be especially careful with this one not to let the solder wick up into here, because you're going to need to count on being able to bend this, as you'll see in a minute. And if you let the solder suck, wick up in underneath that jacket too much, it won't, be as pliable as you really want it to be. All right, so now we got to figure out how we're going to trim this thing. So I want this middle wire is going to go inside of that pin there. Okay? And then the drain wire is going to solder to this little bowl. And you really don't ever want those wires to be able to touch. And so ideally what we want is we want the jacket of that center wire to push right up against that center bowl. Which means if that's what we're going to do, then we want to cut this shield a little bit shorter than the edge of that inner jacket. You see what I'm doing? About like that. That way it's not going to be touching that center pin that this will go into. So now that I got that, I'm going to try to figure out how much to trim off of my center. I've got to take a pretty good bit off here to get that to line up. So let's start with about half and see where we land. That's pretty darn close. I'm going to take just a little bit more. There we go. So now I can get that jacket touching that center bowl. That's going to help make sure that you don't short these things together. Okay? So the first thing we're going to do, whereas last time we soldered the shield last, this time we're going to solder it first, because it is going to sit underneath your center conductor. So if you solder the center conductor first, you can't get your shield wire to the bowl. So first thing, I'm going to heat up this bowl. Now what you're going to do is you got to heat up this bowl here so that it'll let solder stick to it. So you're not just melting the solder. If you just melt a glob of solder and drop it on there, it'll slide right off. Okay? You want to heat up the bowl itself. So you're going to touch your soldering iron to that metal and heat it up as you feed the solder. And eventually you're going to see it flow. There it goes. You see it, how it like kind of went, it stopped being a bubble and it kind of pooled into there. That's how you know that the bowl itself got hot. Okay? And now I can heat it up again. And there we go. Now it's in there pretty good. Now what I'm going to do is I'm going to stick this wire in there. Get it lined up first. I'm not going to pre-tin that pin because it's kind of small and this is a pretty thick wire. And so I found that pre-tinning it can sometimes get you in trouble. But that just means that you got to make sure you heat up the little pin as well. So I'm going to make sure I'm touching the pin and the wire with my soldering iron. And then I'm going to start feeding solder in there. I'm going to get a little bubble like that again, and I'm going to wait for it to pool. Come on, get in there. Get in there. Go, go, go. Why aren't you going? I'm not sure that pooled. Get my sucker. Where's my solder sucker? I might have put too much in there. I just want to make sure that it actually heated up the pin. Oh, it really cooled a lot, didn't it? Okay. Yeah, actually, it looks all right. Yeah, it pooled in there. Yep. I just want to make sure I didn't have a bubble sitting on top and air underneath, because that sometimes will happen. But so I sucked a little bit of that bubble off, and I can see that no, solder definitely pooled in there. So we're good. Now, that is probably good, but because of the way this connector is designed, we want to test it really quick and make for sure that we did not short these two things together inadvertently. So you're going to get your meter out and set it to continuity. Continuity is where it beeps. And I'm just going to test between the tip and the sleeve here. And if I hear no beep, then I'm good. If you hear a beep, you got a problem. That's a cut it off and try again. And that's it. You're going to have to let this cool because it got real hot. But then you can put it back together with wherever the strain relief is. There it is. So you just stick this on here. Oop, wrong way. Come back. Like that. And then you slide that over. Make sure that the little ridge on the connector is poking out a little bit from that barrel. And then you can screw the boot in. There you go. And then you do it on the other side. Questions? Okay. That's how you do the 1/4 inch. So when you get ready for that, you can hop in there. Yes, question?
Sorry, could you explain one more time how to test with the alcohol?
Yeah. So let me see if I can show you here. So here's your meter, or my meter. You're going to have a function here that is called the continuity checker. And it's going to have like a symbol like that, which is the symbol for a diode, or this little wavy thing is like a beep symbol. So that's how you know it's going to beep. And then all you do is you touch your two leads together. And you should hear a beep. If you hear a beep, that means the two leads are touching. You've completed the circuit. Now, in this case, I don't want to have a complete circuit because I don't want the tip and the sleeve on this connector to be connected. So I'm going to touch the tip and the sleeve there. And if I hear a beep, then that means something got connected electrically by accident. You know, either the wire is thicker than I thought, or I dropped a little solder underneath of there or something. But notice if I put both leads there on the sleeve, it's beeping. And if I put both on the tip, it beeps, okay? But there's a little piece of insulation between that tip and the sleeve. And so if the connector's wired correctly, you shouldn't hear a beep. If you do, you've done something wrong. You got to do it again, okay? Does that make sense?
Yes, thank you.
Excellent. All right, any other questions? All right, jump in.